Welcome students. In our last video we have studied about the electrical potential at a point due to a point charge. And in this video let us consider the same electrical potential at a point, but instead of a single charge we are going to consider two charges separated by a small distance. So we are calling it out as electrical dipole. So we are going to calculate electrical potential at a point due to an electrical dipole. So due to electrical dipole, how you can able to calculate the electrical potential at a point P? For that I have drawn a diagram here. See, simple diagram. You consider an electrical dipole here having minus charge or minus Q at A and plus Q at B, separated by a small distance to A. Let O be the center point or the origin, so that this distance corresponds to a distance A and this also corresponds to another A. From that center point O, at a distance R, consider another point to P. Now join the point P and B where the charge plus Q is residing. Let us consider that the distance as R1, and from A to P, let us take the distance as R2. So in order to represent the point P in polar coordinates, that is distance as well as the angle, from the axis, that is axis of the dipole, let us consider from the positive charge, I am considering the angle. From the positive charge to this line, let the angle be theta. What about the remaining angle then? If you are considering this semicircle, it is 180. Already I have marked this angle as theta. So the remaining angle is 180 minus theta. So BOP is theta and AOP is considered to be 180 minus theta. Let us have a small description for this. So what is the small description? You consider like this. Consider two equal and opposite charges, two equal and opposite charges separated by a small distance, that we are considering it as what? Separated by a small separated by a small distance to A, separated by a small distance to A. If you are considering this as the dipole, then you know the dipole moment is P is P vector equal to Q into 2A. Now let P be a point. Let P be a point at a distance. Okay, P be a point at a distance. What is the distance? Small r. From the point where? From the point O. So that the point O, we can say that midpoint of dipole. We can consider this as midpoint of dipole. Okay. Now, if it is the case, let us mark that angle. Let theta be the angle. Let theta be the angle between OP and OP and axis of dipole axis of dipole. Okay. A small description. Similarly, let I have to write R1 and R2. Let R1 and R2 be the distances of the point P, distances of the point P from the charge plus Q and from the charge plus Q and minus Q respectively. So we have written the description. Have this diagram in your mind or draw it again, and with the help of the diagram we are going to derive. See, already we have calculated the potential at a point due to a point charge in the previous case. We are going to use that. So I am writing potential at a point P. Potential at the point P due to the positive charge plus Q. Let us consider that potential as V1. In the last video we have studied that the potential at a point is given by 1 by 4 pi epsilon 0 Q by R. Here from positive charge the distance of the point P is R1. So I am writing here as R1. Consider this as equation number 1. Similarly, you go for the next one. See, potential at the point P due to the negative charge minus Q, which we can consider it as V2. What is the potential? Since it is minus, we can say 1 by 4 pi epsilon 0 minus Q divided by R1. Instead of R1 it is R2, because the charge minus Q and the point P are separated by the distance R2. Take this as equation number 2. See, in our last video, in studying about the important cases, the total potential is given by the algebraic sum. Using that, we can calculate the total potential. Therefore, the total potential is given by, so we can say that the total potential V total at point P is equal to, so we can consider that V total as V, which is equal to algebraic sum of the two potentials, that is V is equal to V1 plus V2. So substitute, we will be able to get it out as V is equal to, what is the value of V? V1 first of all, 1 divided by 4 pi epsilon 0 into Q divided by R1 plus 1 divided by 4 pi epsilon 0 into Q divided by R2. So you can take the common factors and this simplify. You can write like this: 1 by 4 pi epsilon 0 into Q can be taken as common, and remaining 1 divided by R1 plus 1 divided by R2. Take this as equation number what? You take this as equation number 3. See, while studying this, you work these concepts along with me in your notebook so that you can able to see the previous steps very clearly. Now I have to simplify this. How to simplify? I am going to apply a small approximation. Since the distance R, that is from point O to point P, is taken to be very greater than that of the semi length of the dipole A, what I can do, the above equation can be, the above equations or equation can be expressed in or alone, can be expressed in or. How I can do it? I can do it by applying cosine law. So by applying the cosine law, look at the diagram. So I am applying cosine law. You might have studied about this in properties of triangle in mathematics in your 11th standard. By applying cosine law to a triangle, that is, you can see it in your diagram, to the triangle. What triangle means? B-O-P. You just see the diagram. See, in my case the diagram is above. So I will be taking it here. See, when I am considering this diagram, you can very well see the diagram here. You see the triangle OBP. In this triangle OBP, I am going to calculate this R1 or 1 by R1 in terms of R. So after that, I have to take this triangle AOP. In that case, I have to replace this R2 or 1 by R2 in terms of R or 1 by R. How? Let us see. So again, let us consider this. See, when I am considering by applying the cosine law, what I can consider. See, by applying the cosine law to the triangle BOP, what I can able to get. See, you have studied about that cosine law in your 11th standard while studying the properties of triangles. So, you just look at the diagram. So, by applying the cosine law to that triangle BOP, I am writing or I am considering R1. For that, I have to take square. R1 square is equal to other two sides, R square plus A square minus 2RA and the angle. The angle is theta. So cosine of that angle, cos theta. I have to simplify this and I have to get 1 by R1 from this so that I can replace that in equation number 3. How to simplify this? Now, instead of R1 square, you write again R1 square, you take R square as a common factor. When I am taking R square as a common factor, then R square by R square it is 1 plus the next step A square divided by R square minus 2. When I am dividing this by R square, I will be getting 2A divided by R into cos theta. The next step, what I can do? Simply, I can simplify by taking the root. How I can taking the root? For taking the root, what I am going to do is, I am going to apply an approximation. Since A square divided by R square is found to be very, very less than 1, because already here we have stated the distance R is considered to be very, very greater than A. Therefore, A square divided by R square is very, very less than 1. What I can say, since A square by R square is very, very less than 1, we can neglect this. So, we can neglect this term. We can neglect since it is very small. By neglecting, this R1 square can be written as R square into 1 minus, neglect this, 2A divided by R into cos theta. Now you take the square root, you will be getting R1 is equal to, when I am taking the root for R square, I will be getting R. When I am taking the root for this whole quantity, I can put it out as 1 by 2. So 1 minus 2A divided by R into cos theta to the power of 1 divided by 2 or to the power of half. Now, what I have to do? I have to get 1 by R1. So taking a reciprocal, how I can get 1 divided by R1 is equal to, here 1 divided by R. If I am taking this to the denominator, I can write 1 divided by this quantity. Instead, I can write like this. See, 1 minus 2A divided by R into cos theta. When it is taken to the numerator, this half will become minus 1 by 2. Now, what I have to do? How I can simplify this? I have to simplify this using binomial expression or binomially. Why? Since the value A divided by R here is found to be very, very less than 1. Simplify binomially or simplifying binomially. Simplify binomially. That also you have studied it in your 11th standard. I can simplify. 1 divided by R1 is equal to 1 divided by R. While simplifying this binomially, the first term will be as it is. The second term you are having minus. Taking this power to the base, I will be getting minus into minus. will become plus. Then I have to take this power quantity here. So 1 divided by 2. Then multiplied it with 2a divided by r into cos theta. Then the next quantity, the power quantity, which are considered to be less. So I am neglecting the higher terms. Neglecting higher powers. Neglecting higher powers. I am writing the single term alone. So I can get the answer as 1 by r1 is equal to 1 by r into 1 plus 1 by 2, 2a by r cos theta. On simplifying, I can get this 2 and this 2 will get cancelled. Therefore, 1 divided by r1 is equal to 1 divided by r into 1 plus a divided by r into cos theta. Take this as equation number 4. Okay, you work it out along with me in your notebook, and so that you can able to take the previous equations. Similarly, I have to consider the cosine law to the next triangle and simplify. So I have to write again, similarly considering the triangle. The other triangle is AOP, and applying cosine law. And you apply cosine law. What you will be getting, we can write like this. Applying cosine law means r2 square we have to determine. So r2 square is equal to again r square plus a square minus 2ra into cosine of the angle. What is that angle? 180 minus theta. But we know cos of 180 minus theta is equal to minus cos theta. So therefore I can write r2 square equal to r square plus a square plus 2ra cos theta. I have replaced cos of 180 minus theta with minus cos theta, so I can get this. So simplify this as you have done it in the previous case. r2 square is equal to, taking r square common, 1 plus a square divided by r square plus 2a divided by r into cos theta. Since we can write, since a square divided by r square is very less than 1, it can be neglected. So it can be neglected. Okay. So if you are neglecting this, what you can able to get, what is the answer? So when you are neglecting it, the answer that you are able to get is, see, r2 square is equal to r square into 1 plus 2a divided by r into cos theta. Now what I can do, I have to take the square root. What is the square root then? r2 equal to r into 1 plus 2a divided by r cos theta raised to the power of 1 by 2. Now what I have to do? I have to take 1 by r2. So 1 by r2 is again 1 by r. This can be written as 1 divided by 2a by r into cos theta to the power of, instead of plus, I have to write it out as minus 1 by 2. Again, an approximation. Since a divided by r is very less than 1, simplify binomially. Simplify binomially. So when you are simplifying this binomially, what will be the answer? On simplifying this binomially, I can get 1 divided by r2 equal to 1 divided by r into 1 plus, I have to take this to the base, so I will be getting minus 1 by 2, and here I have to write 2a by r into cos theta, and here again neglecting higher powers. Neglecting higher powers. So, when you are neglecting the higher powers and taking the first term alone, 1 divided by R2 equal to 1 by R into 1. On simplifying, you will be able to get minus of A divided by R into cos theta. Take this as equation number 5. See, in equation 4, we have got the expression for 1 by R1, and in equation 5, we got the expression for 1 by R2. Now, you take your notebook and consider the equation 3, 4 and 5. See, by considering or seeing the equations 3, 4 and 5, what I am going to do is, you substitute, okay, you substitute equation 4 and 5, equation 4 and equation 5 in equation number 3. You substitute in equation number 3 the equation 4 and equation 5, you get the answer. How? See, in equation 3 you got V is equal to 1 divided by 4 pi epsilon 0 into Q multiplied with 1 by R1 minus 1 by R2. Instead of minus 1 by R1, I am substituting the fourth equation. Fourth equation is 1 by R into 1 plus A divided by R cos theta. You look at your notebook in the previous page. Minus, then 1 by R2. 1 by R2, I am substituting equation 5. Again, 1 divided by R into 1 minus A divided by R into cos theta. How to simplify this? See, in order to simplify this, in both of these, I am having 1 by R as common. So, V is equal to 1 divided by 4 pi epsilon 0 Q divided by R. You write the remaining, by removing the brackets, you get 1 plus A divided by R cos theta minus, again when you are multiplying this minus with this bracket, minus of 1, then this minus and this minus will become plus A by R cos theta. Now simplify this. See, here you are having the plus 1, here you are having minus 1, that will get cancelled. So add the remaining. What will be the answer? See, the potential V equal to 1 divided by 4 pi epsilon 0 into Q divided by R, multiplied it with A by R cos theta plus A by R cos theta, 2A divided by R cos theta. Simplify this, you can get V is equal to 1 divided by 4 pi epsilon 0 into Q into 2A by R square into cos theta. See, but what is the value of P vector? That is the dipole moment. It is Q into 2A. See, here you are able to get Q into 2A. This can be written as V is equal to 1 divided by 4 pi epsilon 0 into, here I can write it out as P cos theta divided by R square. This we are calling it out as the expression for what? Expression for electrical potential at a point due to the electric dipole, and the SI unit of this potential is volt. See, this expression gives the electrical potential at a point due to electric dipole. So, this gives, or this equation represents the potential at a point. Okay, the potential at a point P due to an electric dipole. Due to an electric dipole. So the final equation that you are able to get is potential V is equal to 1 divided by 4 pi epsilon 0 into P cos theta divided by R square. This can be written in terms of dot product. See, we know that P vector dot or cap can be written as P cos theta, isn't it? Modulus of P vector is P, modulus of R cap is 1 into cos theta, dot product of two vectors. So applying this in the previous equation, I can write this potential V is equal to 1 divided by 4 pi epsilon 0 into P vector dot or cap divided by R square. This is also another form of the electrical potential at a point due to the point charge. See, here we have to discuss some special cases. What are the different special cases? We are having 3 special cases. So let us consider the special cases. And in these special cases, let us consider the first special case. See, when you are considering this diagram like this, isn't it? You are taking the diagram like this. See, this is the center point O. Here you are having minus Q. Here you are having plus Q. And here you are having the point to P. And this angle, let us consider this as theta. See, if you are considering the point to P lies along this axial line is AB. And if the point P is along the line nearer to this positive charge, somewhere here, then what will be the potential? That is the special case. So I am considering like this. If the point P, if the point P lies on the axial line, nearer to the positive charge plus Q, then what will happen? If so, theta will become 0. Because if the point P is here means, then if you are extending this, angle theta will become 0. If theta is 0, cos theta will become 1. Therefore, substituting in this equation, above equation, you write potential is given by the formula 1 by 4 pi epsilon 0 P divided by R square. Instead of cos theta, I am substituting as 1. This is the first special case. What is the second special case? See, the second special case, the same concept, but now I am going to take the point P. See the diagram. I am going to take the point P along the axial line nearer to the negative charge. What will happen? So let us consider the point number 2. If the point P, if the point P lies on the axial line, nearer to minus Q, then theta will become 180 degree, isn't it? From here I have to measure the whole of semicircle. If so, cos 180, that is cos theta will become minus 1. So potential V will be minus of 1 divided by 4 pi epsilon 0 P divided by R square. This we are considering it as the second special case. What about the third special case? See, in order to consider third special case, the point P should be taken on the equatorial line. That is perpendicular on the perpendicular bisector of the axial line or the electrical dipole. So let us consider the point number 3. That is, if this is the dipole having the point minus Q and here is plus Q, and if this is the perpendicular bisector and if the point P is here, what will happen? So the point P is, if the point number 3 or special case number 3, if the point P is on the equatorial line, or lies on the equatorial line, what will happen? Then theta will become 90 degree. If theta is 90 degree, cos theta or cos 90 is equal to 0. Therefore, potential V is also equal to what? Therefore, the potential V is also equal to 0. A single question which will be prolonging to a very long concepts. So, along with me, you write it out or work it out in your notebook and study it. It will be easier for you to write it again or study it. Thank you. Let us move to the next video in the next class.